Hello everyone. We want to start tutorial 3. This tutorial uh, is designed as two parts. Part A covers superposition technique, and part B supports source transformation technique. Now I'm going to start part A, question 1. In this question, the goal is to find I1 with using superposition technique. For this circuit, we have 10 volts here, 8 ohms here, and 2 ohms here, 10 ohms here, and 2 amps here. The I1 is current here. Important key to use superposition technique is to investigate how many sub-circuit we have. Important note, if we have n independent source, superposition technique changes this circuit to n sub-circuits. It means in this question, because we have two independent source, 10 volts and 2 amps, superposition techniques change this circuit to two sub-circuits. And another important key is how we can change voltage and current source to 0. It's very important. If we want to change, for example, a voltage source to 0, it means we should change voltage source to short circuit. And if we want to change current source, for example, I, to 0, it means we should change current source to open circuit. For this question, we want to start with defining sub-circuit for this question. The first part of superposition is obtained for 2 amps is equal to 0. This is first part or part 1. And the second part is obtained for 10 volts should be 0. This is second part. Now we want to start for first part. In first part, we should change 2 amps to 0. And the circuit should be simplified like this. We have 10 volts here and 8 ohms here and 2 ohms here and 10 ohms here, and instead of 2 amps we should use open circuit. The current here is equal to I1 because We are in the first part of superposition. Uh, for this reason, this current calls I1. Okay, here we have infinity, and we learned in the tutorial 1 we can discard this 10 ohms. The circuit should be simplified like this. And we want to find out this current. Immediately, for using Ohm's law, we can say I1 is equal to 10 over 8 plus 2 is equal to 10 and is equal to 1 amp. This is final answer for first part of superposition technique. For second part, we should change 10 volts to 0, which means we should put short circuit instead of 10 volts. The circuit should be simplified like this. We have 8 ohms here and 2 ohms here, and also we have 2 amps here. The goal is to find out current here, and this current is I2 now because we are in the second part of superposition. Now, how we can find out I2? This current is 2 amps, and we can use divided current rule. As you remembered in the tutorial 1, divided current rule says I2, this current, is equal to total current 2 divided 8 plus 2 times 8. The current is equal to 1.6 amps. This is final answer for second part of superposition. And finally, I is equal to I1, final answer for first part, plus I2, final answers for second part. And final answer should be 2.6 amps. Important note, you can solve this question only by KCL and KVL and Ohm's law, and compare your answer for this circuit with this answer, 2.6 amps. To summarize, superposition techniques can convert any circuit including more than one independent source to some circuits including only one independent source. And finally, we should add all of the answers together in order to find final answer. Next question again investigates superposition technique to another question or another circuit. Question 2. In this question, again, we want to find out VO by using superposition technique. The circuit is like this. We have ten volts here. We have 10 volts here and 100 ohms here, and 10 ohms here, and 20 ohms here, and again 20 ohms here, and 5 amps here. The goal is to find output voltage here. Okay, important key, because this circuit has two independent sources, that's why the superposition technique can change this circuit to two sub-circuits like this. In first part, we change 5 amps to 0, and in second part we will change 10 volts to 0. The circuit for first part should be simplified like this: 10 volts here, 100 here, and 10 ohms, and 20 and 20 ohms, and here we have open circuit instead of current source. And output voltage in this step should be Vout1. Okay, important note. 10 volts and 100 ohms here are parallel. That's why the voltage across of 100 ohms is equal to 10 volts. And again, that's why this circuit should be simplified like this circuit. Ten ohms here, and 20 and 20 should be 10 ohms here, and here we have 10 volts. Again, 10 volts and 100 are parallel. That's why 10 volts applied across of 100 ohms, and that's why voltage across of 100 ohms is equal to 10 ohms. Immediately by using Ohm's law, you can find out this current. This current is equal to 10 over 10 is equal to 1 amps. And 1 amps is divided to 20 and 20. That's why the current in this 20 is equal to 0.5 amps. 0.5 amps. And immediately you can find out Vout1. Vout1 is equal to 20 sorry, this current should be 0.5 because 10 divided 20 should be 0.5, and here we have 0.5, and 0.5 divided to 220 ohms, the current for each 20 should be 0.25 amps. That's why Vout1 should be 20 times 0.25 amps and is equal to 5 volts. Okay, to clarify, in first part of superposition, we put instead of 5 amps open circuit and simplified a circuit to this circuit. And by using Ohm's law, we found this current is equal to 10 divided 20. This current is equal to 0.5 amps. And 0.5 amps here divided to 220 ohms, which connected together parallel. That's why the current in each 20 ohm should be 0.25 amps. And finally, we found V out 1 is equal to 5 volts. For second part of superposition techniques, we are changing 10 volts to 0. That's why we should put instead of 10 volts short circuit like this, and this 20 and this 20 should be changed to 110, and we have 5 amps here. We learned in the first tutorial 100 ohms here should be bypassed because it is parallel to short circuit. Immediately we can find out this current. 10 ohms and 10 ohms connected together parallel, and 5 amps here divided to 2.5 amps here and 2.5 amps here. Now we have 2.5 amps here for 220 ohms resistors. That's why immediately we can say the current here is equal to 1.25 amps. And we can find out V out 2 is excess of 20 ohms. And for this reason, which 20 ohms and 20 ohms are connected together parallel, V out 2 is equal to voltage across of 10 or across of this 20, V out 2. That's why V out 2 is equal to 1.25 times 20, or is equal to 2.5 times 10, and is equal to 25 volts. Okay, this is final answer for second part of superposition technique. And finally, V out is equal to V out 1 plus V out 2, and is equal to 5 plus 2 and 5 is equal to 30 volts. This is final answer for this circuit. To summarize, first we started to change this circuit to 2 sub-circuits. In sub-circuit 1, we considered 10 volts and change 5 ohms to 0. And in the second part, we considered 5 amps and change 10 volts to short circuit here. And finally, we found the voltage across of this 20. And important key, again, this 20 and this 20 are parallel. That's why we can calculate voltage across of this 20 or voltage across of this 20 or voltage across of equivalent of 20 and 20 which is 10. That's why in the part 2 we can use 20 times 1.25 or 10 times 2.5. Okay, next question. Again, supports superposition technique. In this question, question 3, we want to find out V out by using superposition technique. For this circuit, we have 2 amps here. We have 10 ohms here. And we have 8 ohms here. And 20 volts here. And we have 4 amps here. Here we have 5, and output voltage is defined voltage across of 5 ohms. Okay. You can solve this question by other techniques and compare your answer with other answers. Important key for this circuit is to investigate how many dependent source we have and how many sub-circuit we can generate by superposition techniques. In this circuit, we have 3 sources. That's why superposition technique generates 3 sub-circuits. Superposition technique generates 3 sub-circuits. Sub-circuit 1, we consider 4 amps and change 4 amps to 0 and 12 volts to 0. We consider 2 amps here, and for this 12 we should use short circuit instead of this 12, and here we have 5, and for 4 amps we should put open circuit instead of 4 amps. And also we define output voltage in this part V out 1. This is first part of superposition technique. In second part, again 4 amps should be 0 and 2 amps should be 0, and only we are considering 12 volts. The circuit should be like this. 10 ohms here, 8 ohms here, 12 volts here, and 5 volts here. The output voltage in this part should be V out 2. And for third part, 2 amps should be 0 and 12 volts should be 0, and only we are considering 4 amps. The circuit should be like this. We have 8 ohms here, 10 ohms here, and 5 ohms here, 4 amps here. The output voltage in this part define V out 3. Okay, again, we have 3 sub-circuits which generate by superposition technique. In first part, only we have 4 amps, we have 2 amps, and we put instead of 4 amps open circuit and instead of 12 volts short circuit. In part 2, only we have 12 volts and we put instead of 4 amps open circuit instead of 2 amps open circuit. In part 3, we have only 4 amps and we put instead of 2 amps open circuit and instead of 12 volts short circuit. Now we can use KCL and KVL for solving any sub circuit. And you can see solving any sub-circuits is easy, and only we have a simple circuit and we can solve for using only one equation and also define one unknown. In next page we can solve sub-circuits and find out V out 1, V out 2, and V out 3, and finally we can add together in order to find out V out. Okay, for part 1, let me have again circuit. We have 2 amps here, 10 ohms here, 8 ohms, and 5 ohms here, and also here we have V out 1. Okay, we can use divided current rule in order to find out this current. This current, for example, I out 1. I out 1 is equal to divided current rule says we have 2 here, 10 plus 8 plus 5 here, and times 10 here. This is I out 1 is equal to 20 divided 23, and immediately we can find out V out 1. V out 1 is equal to 5 times I out 1 and is equal to 100 over 23. This is final answer for part 1. Okay, for part 2, we have circuit like this. We have 12 volts here, and we have 5 ohms here, 8 ohms here, 10 ohms here. We want to find out V out 2 here. Immediately you can use divided voltage rule. Divided voltage rule says we have 12 here, total voltage, divided 8 plus 10 plus 5 and times 5. That's why V out 2 is equal to 60 over 2 3. Important note in this part is uh, we should put here negative. Why? We should put here negative and also here negative. Why? Because the positive and negative for output is this positive and this negative. And the current travels in circuit for this direction. That's why in part 2, V out 2 is equal to minus 60 over 23. This is important in order to find out final answer. This is final answer for part 2. And for part 3, the circuit is like this. We have 4 amps here and 8 ohms here and 10 ohms here, and also we have 5 ohms here. We want to find out VO3. Okay, in order to find out VO3, we should find out this current. This current, which we call IO3. How we can find out this current? We can use divided current rules. Divided current rules says IO3 is equal to total current 4 divided 8 plus 10 plus 5, 15 times 8 should be 32 over 23. And immediately you can find out VO3 is equal to 5 times IO3 is equal to 160 over 23. This is final answer for part 3. And finally, V out is equal to V out 1 plus V out 2 plus V out 3, and is equal to 8.96 volt. This is final answers for original signals. Be careful when you are adding. You should be careful about minus in V out 2. I mean here we should put, instead of V out 1, 100 divided 23, instead of V out 2 minus 60 over 23, and instead of V out 3, 160 over 23. Okay, in next part B, we want to discuss about source transformation method, which is a simple and easy method, but it's very important in order to solve any question with simple way. Question 1. Okay, in question 1, we want to find out V1 by using source transfer method. The circuit is like we have 2 amps here and 5 ohms here and 6 ohms here and 5 ohms here and 2 amps here. The goal is to find out voltage here, V1 here. Okay, let me explain source transformation method. If this technique says if we have a voltage here and a resistor here, we can transfer or change this voltage and resistor to current source like this. This resistor should be same here and the current should be V over R. And also we can use inverse transformation. That's why we can change voltage source to current source and current source to voltage source. Important aspect of this method is direction of current. This direction of current should be same as this direction of currents. And the value of the current source is equal to voltage divided R. Now we want to solve this question by source transformation. We want to change this current and this current source to voltage source. The circuit should be simplified like this. We have voltage here and resistors here. This resistor is 5 and voltage here is equal to 2 times 5 is equal to 10. And also here we have 6 and again here we have 5 and here we have 10 volts. This 5 is equal to this 5. Okay. Let me change the value of this current to 0.2. That's why here we have 1 volt instead of 10 volt. Again, here we have 0.2 amps. For this 5 should be changed to 0.2 times 5 is equal to 1 volt. And here we have 2 amps. 2 amps for this 5 should be 10. Now we want to apply KVL in this loop. In order to apply KVL in this loop, we have positive, negative, and positive, negative here. And we want to start with defining, for example, I here. Okay, KVL says minus 10 plus 5 times I plus 6 times I plus 5 times I uh, plus 1 is equal to 0. That's why we have 16I is equal to 9. And that's why I is equal to 9 over 16. And immediately we can find out V1. V1 is equal to 6 times 9 over 16. This is final answer for V1. Okay, once again, we solved this question by using source transformation method. Of course, you can use, for example, only KCL and KVL rules for this technique, for this circuit, and only you can use, for example, superposition technique. Uh, it's useful way in order to understand all of the technique for circuit. It's very important for this question. You solve this question, for example, by a superposition technique and compare your answer with our answer. Next question again covers source transformation method. In this question, question 2, we want to find out current I by source transformation method. The circuit is like this. We have 20 ohms here and 5 volts here. We have 10 ohms here. Also, we have 5 ohms here. And we have 10 volts here. The current is this current. We want to find out this current. Okay. For this question, we want to change this voltage source and this voltage source to current source. And after that, we can find out I by using simple equation. This 5 and this 20 should be changed to current source like this. The value of the current source should be 5 over 20. 5 over 20 is equal to 0.25 amps. And the value for resistor is the same, 20. And also we have 10 here. And for this 10 volt, again we have 5 ohms here. And we have a current source for this value, 10 over 5 is equal to 2 amps. The goal is to find the current here. The current here, I. Okay, we can simplify this circuit to this circuit. 2 amps and 0.25 amps should be simplified to one source with value 2.25 amps. And this 5 ohms, and these 20 ohms are parallel and should be simplified to one resistor. And we have 10 here. And this circuit is 20 parallel to 5. The value for this resistor should be 4.8 ohms. Now we want to find out this current, I. In order to find out this current, you can use immediately current divided rule. Current divided rule says I is equal to total current 2.25 divided 10 plus 4.8 times 4.8. The total current I is equal to 0.72 amps. This is final answer for this question. Okay, in next tutorial, we want to discuss about important technique which calls Thevenin theory. And for this technique, we want to solve some question in order to understand and realize important concept about this technique.